In this session, you are going to know about the cloud distribution architecture. What is a cloud distribution architecture? Cloud architecture, in the architecture, you have a 8 different architectures are there. The first one here is a workload distribution architecture. What is a workload here? The workload distribution. How can you distribute the workload? Who will distribute the workload? Here, the workload is a abstraction of actual work. That your instance or a set of instances are going to perform. That means this kind of abstraction of actual work. For the abstraction of actual work, that is indicates that workload here. Who will perform this work here? The instances, your instances are set of instances are going to perform. That's called here workload. Here the workload distributed by the load balancer. Here in this diagram shows that the middle part here, there is a cloud service consumes are there. These are all consumers, but means different client. Let us assume the consumer in the sense you will use the cloud and then provide in the sense you will provide the cloud. For example, AWS is a provider. Consumer in the sense that means I am going to storing the data into the cloud, processing the data from the cloud. That is a person called as a consumer. The consumers may be organizations like that. Here the load balancer. The load balancer distributes the okay. That is a load balancing. The load balancing, the load balancer that provides a runtime logic capable of distributing the workload among the IT resources. The load balance, the main work of load balancing is a distribution of distribution of different tasks among the IT resources. Here it distributing the tasks to different resources. That is called here load balancing. In particular load balancing, here for example in the right side diagram, the redundant copy of cloud service A implemented on a virtual server B. Here we have a different services are there, service A and then service B, and then the corresponding servers are there, the virtual server A, virtual server B, and then there is a load balancing. That means there is a different tasks are there. These tasks are managed by these tasks are managed by different. That means the load balancer, the main aim of load balancer here is a distribution of different tasks. That is a load balancer. And then coming to the next important here is a resulting workload distribution. The resulting workload distribution architecture. The, the resulting workload distribution architecture reduces the IT resources. Why? Because so much here having the different servers. That means virtual servers are there. Virtual server A, virtual server B. That means the load balancer distributing these tasks. That means that's why it reduces the both IT resources over the utilization and under the utilization to extend it depends upon the sophistication of the load balancing algorithms and runtime logic. Here in this case, the fundamental architecture model can be applied to IT resources with workload distribution commonly carried out in support of distributed virtual servers, the cloud storage devices and cloud services. That means in addition to these information, the distributed virtual servers. That means distributed virtual servers in the sense we will task performing the distribution. The task distribution is there, cloud storage devices, and then cloud services. So many different cloud services are there. Those are carried out. That means in support of these information, with the distribution IT resources and applied to the IT resource and with workload distribution. And then load balancing system can be applied to specific IT resources, and then it produces a specialized variation of the architecture. In the that means load balancing, some of the things are there. The load balancing architecture, the service load balancing architecture, load balanced virtual server architecture, load balanced virtual switches architecture. We will discuss later about the all these architectures. Here, that means these are all advanced architecture. You comes under the advanced architecture. You have a different architectures for the specific IT resources. In addition to these load balancer mechanism, the virtual server and cloud storage device mechanism to which the load balancing can be applied. The following are the advanced mechanism can be a part of the cloud architecture. What are the advanced mechanisms here? The audit monitor, cloud usage monitor, hypervisor, logic network, perimeter, and then resource cluster, resource replication. These four are these six are some of the mechanism for the workload distribution architecture. Here, the mechanism first one is a audit monitor. Here, what is the audit monitor here? When distributing the runtime workload, the type and geographical location of IT resources that process the data can be determined and whether the monitoring is necessary to fill the legal and regularity requirements. For the filling the regularity requirements here, you are using the audit monitoring. That means at the time of distributing the runtime workload, the workload in the sense abstract task. That means at the time of running the workloads, the type and geographical location of the IT resources that are that process the data can be determined whether monitoring is a necessary to fill the legal and the requirements. Then the second one is a cloud usage monitor. Here, what is a cloud usage monitor? Various monitors can be involved to carry out runtime workload tracking and data processing. Here, in order to do runtime workload tracking and data processing done by using some of the monitors. Those monitors you call it as a cloud usage monitors, and then hypervisor. You know very well about the hypervisor. Hypervisor is the connectivity between to our hardware as well as the virtual machine or operating system. Here, the main role of hypervisor, the work in the workload distribution, workloads between a hypervisors and virtual servers that that they host may require a distribution. The logical network perimeter. This is one of the mechanism. What is the logical network perimeter? The logical network perimeter isolates the cloud consumer network boundaries. That means isolates the consumer. Isolates in the sense, for example, isolation in the sense, if any transaction fail, that cannot affect it to the other transaction. That means the consumer boundaries are there. If the one person, for example, SV University uses a one certain boundary, that means that is like a consumer, or one of the consumer. For example, Sri Vidyanikethan is one of the consumer. They have their boundaries. If they will not cross their boundaries, if anything happen in a SVEC, that means SVEC boundary, that cannot affect it to the SV University boundary. That means that is called here this logical network perimeter. The cloud consumer network boundary is in relation to how and where the workloads are distributed. Here, coming to the resource cluster. Here, what is a resource cluster here? The clustered IT resources in active mode are commonly used to support workload balancing between a different cluster nodes. Here, that is a resource cluster. That means the cluster IT resource in a active mode are commonly used to support the workload balancing. And then another important one, resource replication. Here, generate new instances of virtual IT resources. That means that is a replication. A number of replications are there. That means this mechanism can generate a new instances of virtualized IT resources in response to the runtime workload distribution demand. That means for the demand, if you need extra resources, that means automatically generates this mechanism. Here for referencing, this is a referencing information. See the referencing if you have any doubt on the workload distribution architecture. Here coming to the cloud architecture, the second important one, resource pooling architecture. What is a resource pooling architecture? How can you performing this resource pooling architecture? What are the different types of resource poolings are there? Here you will know about all these concepts now. Here, resource pooling architecture. What is a resource pooling architecture? Resource pooling in the sense that is combination you are using. The resource pooling architecture is based on the use of one or more resource pools. Based on not a single one. It's based on a one or more resource pools in which the identical resources are grouped. That means some of the, for example, all physical servers grouped as a one resource pool, and then all virtual servers grouped as a one pool, and then memory pools are there. That means all memory related concepts, related RAMs are grouped as a, that means this is called here resource pooling. The resource pooling architecture. Here, in this case, identical resources are grouped and maintained by the system that automatically ensure that they remain synchronized. They remain synchronized. That is called resource pooling. And then some of the common resource pools are there. Here, the common resource pooling techniques. Here, physical server pool, virtual server pool, storage or cloud storage device pool, network pool, that is called it as a interconnected pools, and then CPU pools, and then these are all different pooling techniques. That means resource pooling mechanisms. The first one here is a physical server pool. The physical server pool consists of network server here that have been installed with the operating system and other necessary programs and applications. Here, what is the thing here? It consists of network servers. You have a physical server, server one, for example, Oracle virtual. That means server pool two. Oracle servers are there, different server. That means these are all are physical servers. Here it consists of network server that have been installed with the operating system, and then programs, and then application, and are ready for immediate use. Those are all called as a physical server pools, not a single one. It's having the n number of servers. Coming to the virtual pool, the diagram shows the four different virtual servers are there. The virtual pools are configured using one of the several available templates. Here, that means those are all selected. That means selected by the cloud consumer during the provisioning. For example, the cloud consumer can set up a pool of mid-tier Windows server with 4 GB RAM, and then a pool of lower tier Ubuntu server with 2 GB RAM. That means in this way you will selecting the, that means at the time of already you created in a, by using VMware. With the VMware you selected 440 GB RAM. That means like that you are taking such kind of information. That means the some of the information, with that information you are selecting. That means the consumer itself selecting this information. That is called here virtual server pools, storage pools. That means combination here are cloud storage device pools. Here it consists of file based or block based storage structure. That means every virtual related information stored in a file or group of file. That's why it consists of file based or block based storage structure that contain empty or filled cloud storage devices. That is a storage pool, and then network pool. That means the interconnected pools are, that means these are all network pools consist of free configured network connectivity devices. Free configured network connectivity devices are there. Yet these devices may be firewall devices, physical network switches. These are all different devices here. Yet these devices connected, that means how can you connect these devices here? Created for the redundant connectivity, load balancing, link aggregation, redundant connectivity. For these purposes, you are using these network pools and then CPU pools. Here in the right side diagram, different CPU pools are there. That means the group CPU groups, they're just like to be allocated to virtual servers and are typically broken down into a individual processing cores. That means you can performing by using CPU pools. The memory pools, the pool of physical RAM can be used in newly provisioned physical servers or to vertically scale the physical servers. For this purpose, you are using these memory pools. The dedicated pools can be created for each type of IT resources. Another one is a dedicated pools. For example, I am taking the bunch of pools here. Here CPU pool, memory pool, storage pool, and then network pool. Are dedicated. These are all called as dedicated pools. The dedicated group of information can be created for each type of IT resources, and individual pools can be grouped into larger pools. That means a combination of different pools you are taking as a dedicated pools. Here in this case, the case each individual pool become the sub pool. For example, the memory pool is a sub pool of the dedicated pool. CPU pool is a sub pool of the dedicated pool. Storage pool is a sub pool of the dedicated pool. That is called here different pools. Next one, resource pools. The new resource pool become a highly complex with multiple pools created for the specific cloud consumers or application. Here in this case, hierarchical structures can be established. Here the structure pool A, pool B, pool C. That means in the structure, the different layers are there. Layer pool A, pool B, pool C, different layer. In the virtual servers, CPU pool, memory pool, and then robot pool. That means that's a network pool. That means you group it in a top layer. After that, in the middle layer, you are doing the some of the virtual pool, CPU and memory, and then CPU, memory, and then network is a bottom pool. That means your hierarchical structure, you are forming the hierarchical structure. The hierarchical structure can be established to form a parent, sibling, and nested pools in order to facilitate the organization of diverse resource pooling requirement. In order to get the diverse pooling requirement, you are forming the parent, sibling, nested pools. That is next you will discuss about the what is the sibling pool, what is a nested pool. Here, sibling. What is a sibling here? Sibling in the sense some connectivity to the root. That means, for example, your brother, sibling of you, like that. The sibling resource pools are usually drawn from the physically grouped IT resources, as opposite to the resources that are spread out over the different data centers. The sibling pools are isolated from the one another. That means they don't know about the if any one sibling field that cannot affect it to the other sibling. So that each cloud consumer is provided access to its respective pools. Coming to the nested pool. Here, what is a nested pool? Here you have a nested pool within another one. The nested pool can be used to assign a resource pools to different department groups in the same cloud consumer organization. And then after resource pools have been defined, the multiple instances of IT resources from each pool can be created to provide an in-memory pool of live IT resources. That is a simple information. In addition to cloud storage devices and virtual servers, which are common pooled mechanisms. That means sibling pools, memory pools, like that different. And then coming to the some of the mechanisms for the resource pooling architecture. The following mechanism can be a part of this cloud architecture. What are the mechanisms here? Same audit monitor, cloud usage monitor, hypervisor, logical network perimeter, and then pay per use monitor, remote administration system. These are all, and then not only that one here, resource management system, resource replication. These are eight are the different mechanisms of the cloud architecture. The cloud architecture, what is the architecture here? Resource pooling architecture. For the resource pooling architecture, these are all mechanism. The first mechanism here is a audit monitor. Here what is a mechanism? Already we discussed about the in the previous pooling, previous architecture. Audit monitor, that means this mechanism monitor the resource pooling usage to ensure the compliance with the private and regulation requirements. And then what is the necessity of this pooling here? That means it consists of devices or data loaded into the memory. That means it consists of cloud storage devices. That is a data, the cloud storage devices as well as the data loaded into the memory. Next one, cloud usage monitor. What is the cloud usage monitor here? Various cloud usage monitors are involved in a runtime tracking. In the runtime tracking, you have to involve in the different usage monitors. And then synchronization, cannot allow synchronization in the sense you are doing one process, another process cannot allow in that loop. That means are required by the pooled IT resources, any underlying management system. That is a cloud usage monitor. Hypervisor, hypervisor in the sense very well, that is the connectivity. This mechanism, hypervisor mechanism, is a responsible for providing the virtual server with access to the resource pools. That is a simple mechanism. That means in addition to hosting the virtual servers and sometimes the resource pool themselves, the logical network perimeter one. The logical network perimeter is used to organize and isolate the resource pools. That means for organizing the different IT resource pools, you are using the this network perimeter mechanism. And then pay per use monitor. Pay per use monitor mechanism collects the usage and billing information on how individual cloud consumers are allocated and use IT resources for the various. The main important thing here is a pay per use in the sense whatever you use, pay per only that thing. That is a, that means in this case it mechanism collects the usage and billing information. The usage and billing information. The remote administration system. What is the mechanism here? This mechanism used to interface with the background system as well as the programs in order to provide a resource pool administration users by using front-end portal. That is a remote administration system. And then resource management system. What is a resource management system? It is a mechanism. This mechanism supplies the cloud supplies the cloud consumers with the tool and permission management options for administering resource pools. The resource replication. Here, the resource replication is used to generate a new instances of the IT resource for the resource pools. And then these are all some of the information about the resource pooling architecture. Okay, ma. Thank you.